Hello everyone, this is the first part of the first lecture of week 9 where we study this new object which is called Laplace transform. Laplace transform is a special integral operator which takes a function and transforms it to some another function. Let me give you precise definition of the Laplace transform. Let f be a function on semi-interval from 0 to infinity. The Laplace transform of f is a new function. Let's call it capital F, defined as follows. So f at a point s, this is by definition the integral from 0 to infinity e to the minus st f of t dt. So what this Laplace transform does, it transfers the function to a new function which you can construct as follows. You take the original function multiplied by e to the minus st, then you integrate the product with respect to the same variable t. And you can notice here that the integral is from 0 to infinity, so this is improper integral. Let me remind you that the improper integral by definition is a limit and approach to infinity from 0 to n of this expression. And so we can see that since we have a limit here, sometimes this limit may exist, sometimes it may not exist. So the domain, the values of s for which the integral exists, is called the domain of this Laplace transform. The domain of f is the set of all values s such that the integral above exists. Okay, so and also the notation, we usually use the notation for Laplace transform is denoted as L, and here we write curve brackets of f. So Laplace transform of the function f is this function capital F above. Let's consider an example. Let's say example 1. Let's just take the simplest function. So let f of t be the identity function, so is 1 for non-negative values of t. Let's find the Laplace transform of this function. The Laplace transform of the function f at a point s is the integral from 0 to infinity e to the minus st times the function dt. So times 1, right? Or this is just integral from 0 to infinity e to the minus st dt. And now let's use the definition of improper integral. The limit from 0 of the integral from 0 to n e to the minus st dt. Now let's integrate. So the integral of e to the minus st with respect to t is 1 over minus 1 over s. So s now is a constant here, and e to the minus st and the integral is from 0 to n. Now let's substitute the values. This is when we substitute n, we get e to the minus Sn. Minus, when we substitute 0, we have just minus 1 over s. With this minus will be plus 1 over s. And now let's have a look at this limit and think when the limit does exist. So this part here on the right hand side just a constant, and the first summand here, the dependence on n in the power of exponent. So you see, if the power of exponent is negative, then it approaches to 0 and the limit of course exists. If the power of exponent is positive, then everything approaches to infinity and the limit does not exist. So we need to find s when the power is negative for this limit to be exist. So this is true when s is strictly positive, right? Because when s is positive, we have here negative power, and n approach to infinity, e to the power minus infinity approach to 0. So this is true when s is positive, and in this case, this part here is 0, and we have just 1 over s.